we'll have we'll be recording this section for this. Here we go. Section 2, real numbers. I'm not completely happy about that name, real numbers. They're no more nor less real than other types of numbers, but that's an historical thing. So, real numbers. The concept has two meanings. There's an analog or geometric meaning, and there's a digital or arithmetic meaning. The analog meaning for a real number is that it's a ratio of lengths of lines. So if you have a square, for example, the diagonal is b and the side is a, then the ratio b over a is the square root of 2, a real number. Or we have a circle with circumference, distance around of c, and a diameter d, then c over d is pi, the number pi, about 3.14159. Okay, so these are the analog definition of meaning of a real number. The digital meaning is that they're infinite decimals. Square root of 2 is 1.4142135562, and so on forever. Pi is 3.14159265535, and so on forever. This ... means that these are only approximate values for these real numbers. Although, of course, up to after this is 9 places, so these are less than a billionth. So these are close approximations. Now, okay, real numbers have a number of rules that always apply. We call them laws, which means they're more applicable than human laws. Anyhow, so here these are two are what I call the commutative law. The order of addition and the order of multiplication doesn't matter. X plus y is the same as y plus x, xy equals yx. These two are the associative laws, the way you bracket plus and times doesn't matter. X plus the quantity y plus z is the quantity x plus y, that plus z. X times the quantity y times z is xy times the quantity z. So it doesn't really matter where the brackets are. And then there's here the distributive law. X times y plus z is xy plus xz. Then some other laws. 1 times the number is itself. -1 times the number is its opposite. 0 times the number is 0. The opposite of the number is a number. -a times b is a times -b is the negative of ab. And -a times -b equals ab. The real numbers are arranged on a line, the real number line. Imagine a line and you label 1 point here 0, and you choose a unit distance and put the 1 here. Twice that will be 2. 1 in unit distance and backwards to the left is -1. Backwards again, 1 unit is -2, and so on. And there are numbers in the middle. Here be 1/2, -1/3. Over here be pi, and so on. Because it's on a line, we order numbers on it from left to right. If x is to the left of y, then we say x is less than y, or equivalently, y is greater than x. X is less than or equal to y means x is less than y, or x equals y. This is x greater than or equal to y, which means that x is greater than y, or x equals y. And in general, given two numbers x and y, either x is less than y, or x equals y, or x is greater than y. X is to the left of y, or it's on y, or it's to the right of y. Trichotomy, there's 3 cases. This phrase, a less than x less than b, means that a is less than x, and x is less than b, so it's between a and b. If a is less than x and less than b, then you can draw an interval. These are the possible points x for which this is true. We denote that in this interval by this notation: round bracket a comma b round bracket. A less than or equal to x, less than or equal to b. This is an interval where we include the endpoints, where here we excluded them. So this is called a closed interval, and this is called an open interval. We denote this open interval by square bracket a comma b square bracket. Then there are mixed cases where we include b but not a. A less than x less than or equal to b. This is a half open interval. Round bracket a to b round the square bracket. Here we include a but not b. A less than or equal to x less than b. So this also is a half open interval. Square bracket a comma b round bracket. Here we have half lines. A less than x, everything to the right of a. We denote that by round bracket a to plus infinity round bracket. We put a round bracket here because it goes off to positive infinity, but never reaches it. So it's like this circle here. Here, a less than or equal to x, it includes a and everything to the right of it. So square bracket a to positive infinity, round bracket. Here, x less than b, it's everything to the left of b. So negative infinity to b, round bracket. This is x less than or equal to b, everything less than or equal to b. So b and everything to the left of it. This interval is denoted round bracket negative infinity to b, square bracket. The absolute value of a number is denoted by line x line. It denotes how far x is from 0. So the absolute value of x is x if it's positive or 0, and it's its opposite, thereby giving a positive sign that x is less than 0. So for example, the absolute value of 17 is 17, the absolute value of negative 17 is 17, and the absolute value of 0 is 0. Because we always put a positive sign on a number when we take its absolute value, the absolute value is always greater than or equal to 0. X and its opposite are the same distance from 0, so they have the same absolute value. Absolute value of x times y is absolute value of x times absolute value of y. Absolute value of x over y is absolute value of x divided by absolute value of y. This absolute value just affects the sign, not the numerics. The distance between a and b, we'll denote that by d of a comma b. It's the absolute value of the difference a minus b. And that's the same thing as the absolute value of the difference b minus a. So the distance from a to b is the same as the distance from b to a. So we have some examples, exercises from P2. Simplify. 3 times x plus y, what's that? Well, we distribute the 3. 3x plus 3y, like this. 4 times 2m, what's that? Well, we move the brackets, 4 times 2 times m, and that's 8m, a simpler expression. Here we have something a little complicated. Negative 5 halves times 2x minus 4y, what's that? Well, first we'll distribute the negative 5 halves over these two terms. So you get negative 5 halves times 2x minus negative 5 halves times 4y. Okay, here we use associative law to move the brackets around. Negative 5 halves times 2, that times x, minus negative 5 halves times 4, that times y. Okay, a bit of arithmetic. Negative 5 halves times 2 is negative 5. Negative 5 halves times 4 is negative 10. So negative 5x minus a negative 10x. Now minus and negative cancels, so we get negative 5x plus 10y. That's the answer for this. Here we have some questions as to order. Is negative 8 greater than 1? Yes or no? No, it's not. In general, a negative number will not be greater than a positive number. Is 8 less than or equal to negative 8? Again, no. A positive number will not be less than or equal to a negative number. If ever you have some problems about this, ask yourself it in terms of credit and debt, because the negative numbers were literally invented to cover the concept of debt. So if ever you're, for example, 1 is less than 8, right? How about negative 1 and negative 8? Which is bigger than which? Anyone? Is negative 1 greater than negative 8, or is it negative 1 less than negative 8?
Negative 8 is less than negative 1.
That's correct. You'd rather be $1 in debt than $8 in debt. So there you are. Okay, this is talking about set theory. A set is a collection of, in this case, numbers. These are finite collections, whatever. Union, A union C, is a set of numbers that are in either set, one or the other. This is intersect. A intersect C is a set of numbers that are in both sets. For example, A union C is all the numbers that are in this or this, which tends to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A intersect C is a set of numbers that are in both, and that's just this, number 7. Okay, find their union and their intersection. Their union is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Their intersection is empty. There is no number that is in all three of these sets. So we denote that by empty brackets. We call that the empty set, 0 with a slash through it. asked to express as an inequality in an interval notation. What is this interval? Well, it's -4 to -1 square bracket, round bracket. -4 is less than or equal to x is less than -1. This interval includes 1 but not 4, so it's square bracket 1 to 4. 1 less than or equal to x less than 4. This includes -3 and 3 and all between, so square bracket -3 to 3. So -3 is less than or equal to x is less than or equal to 3. This includes everything between -3 and 3, but not the endpoints. So this is the open interval, -3 to 3. The inequality is -3 less than x is less than 3. Here they ask for the distance between 2 and 17. How far are they apart? Well, the distance is the absolute value of 2 minus 17. That's the absolute value of -15, which is 15. What's the distance between -3 and 21? Well, it's the absolute value of -3 minus 21, which is the absolute value of -24, which is 24. What is the distance between -38 and -57? It's the absolute value of -38 minus -57. After a bit of work, that's absolute value of 19, which is 19. So there's that. Now here's a tricky one. We get what are called infinite repeating decimals. 0.7777777, etc. We'll denote that by putting a line over the repeating part, 0.7 line. They ask to express that as number divided by number. What is that? Well, here's the trick. We call it a number x, 0.777. If you multiply it by 10, that shifts it over one repeating block, 7.777, etc. So if you take the difference between these two, 10x minus x, then the repeating part disappears. 7.77, etc., minus 0.77, etc. The 0.77 forever goes away, and we're left with 7. So 10x minus x is 7. So 9x equals 7. So x equals 7/9. That's the fraction solution to this value. But here we have something a little, be careful here. 0.257, then the 57 is repeated. So it's not 0.2, 57, 57, 57, 57. It doesn't repeat 257, 257, 257. That's a different number. But this one with the 57 repeating, what is it? Well, let x equals 0.2575757, etc. 100x moves it over 2 spaces, so 1 block, repeating block. So you get 25.75757575, etc. You notice that this 5757 part is identical. So if you take the difference, 100x minus x, then it'll be this one, 25.75757575 minus 0.2575757, and the 5/7 tail, infinite 5/7 tail, cancels, and you're left with 25.5. So 100x minus x, that's 99x. It equals 25.5. So transpose, x is 25.5 over 99, or rescaling numerator and denominator by 10, we get the ratio 255 over 990, which if you plug into the calculator will indeed come out to be this repeating decimal. Okay, I believe we've concluded our 2 sections.